Hello everyone. Today we are going to learn how you can find eigenvalues of 3 into 3 matrix. In my previous lecture I have told you that how you can find the eigenvalues of 2 into 2 matrix and the eigenvectors of 2 into 2 matrix. I will also give the links in the description if you want to look for those lectures also. So it's just the same as we have used in 2 into 2 matrix, but the method that is different is how you can find the determinant of 3 into 3 matrix, while the rest is same. So let's start. The equation that we have used in 2 into 2 matrix is the characteristic equation, and that equation is determinant of A minus lambda I equals to 0. Now this is the same equation that we have used in the 2 into 2 matrix, and in the 3 into 3 you have to use the same. What will be the different? Let's see. So I will write here again as the determinant of, now what I will do, I will put the values here. So what is A? A is the matrix, so I'll write here as the given matrix, that is 4 0 0 1 3 0 2 minus 1 2. So this is the given matrix minus lambda I. What is I? I is the identity matrix. As this is a 3 into 3 matrix, it means 3 rows and 3 columns. You have to use the identity matrix of that is of order 3 into 3. So it will be 1 0 0 0 1 0 0 0 1. So in the identity matrix there is a 1 in the diagonal. So we have just put these values in the given characteristic equation, and now we will solve it. What we'll do is determinant of, now what we'll do, we'll just solve it as 4. Now what we'll do, we will subtract this, but we have to multiply this lambda with each and every element of this matrix, that is identity matrix. So I'll do it as 4 4 minus lambda. Then I will subtract the second entry of both the matrices, the corresponding entries from each other. Then 1 minus 0, then 2 minus 0, and then 0 minus 0, and then 3 minus 0, and then 3 minus lambda, because lambda multiplied by 1 is lambda, and the rest will be 0. And then minus 1 minus 0. Then the last row is 0 minus 0, then 0 minus 0, and then 2 minus lambda. So you can see here that lambda will be in the diagonal because all the ones were in the diagonal in the identity matrix. So we have to equate it to 0. So the final equation that we will get is, I'll write here, the final matrix that we will get is of which determinant we need to find is determinant of 4 minus lambda. 1 minus 0 is 1, 2 minus 0 is 2, 4 minus lambda 1, then 2, then 0, then 3 minus lambda, then minus 1, then 0, 0, and 2 minus lambda. So this is the final matrix, that is 3 into 3 matrix, of which determinant we will find, and through which we will find the values of lambda, that is the eigenvalue. Lambda is the eigenvalue of which values we are going to find in this in today's lecture. Keep this in mind. This is a 3 into 3 matrix. You can have you just need to use the method of finding the determinant of 3 into 3 matrix. I will also give the link here down in the description how you can find the 3 into 3 matrix in just few minutes. So you can refer to that video. So how we can find the determinant? Now let's see. The next is, we'll go here. So determinant will be, the easiest method is what we have to do. First we will take this entry. I'll write 4 4 minus lambda, and then what I will do, I will delete this column and this row, and I will take take these 4 elements, and I will take their determinant, that is 2 into 2. So I'll write here 3 minus lambda, minus 1 0, and 2 minus lambda. Same is the case for the rest of entries. So now the next entry will be with the minus, and now I will use different color, that is blue. This 1, minus 1, I will write 1 here. Then the 2 into 2 matrix will be, I have to ignore this column and this row, and I have to take the rest of the elements. So those will be 0 0 minus 1 2 minus lambda. Then the last one will be, I'll use the green color. So the last one will be with the plus sign, and we'll take this element, that is 2. And what will be the 2 into 2 matrix? It will be, we have to ignore this row and this column. It's just getting messy, but it will help you to understand. 2. So what we will have, 0, 0, 3 minus lambda and 0. So this is the easiest method to find the determinant of 3 into 3 matrix. Now let's see how we will, and it all will be equal to 0. We have to equate it to 0. Now let's solve them as 4 minus lambda, and then we have to take the determinant of 2 into 2 matrix. It will be like, we have to multiply the diagonals and subtract from each other. So 3 minus lambda into 2 minus lambda, it will be 3 minus lambda and 2 minus lambda minus the 0 into minus 1 will be 0. So I'll not take that entry. So 4 minus lambda will be multiplied by 3 minus lambda and 2 minus lambda, like this. Then minus 1 into 0 minus 0. So it will be 0. It will be 0 because all the entries are 0. Then plus 2, and again all the entries are 0. And we will equate it to 0. So what left is, I will change the color. So 4 minus lambda, we will compare 4 minus lambda equals to 0 with the 0, and 3 minus lambda into 2 minus lambda. Another is 3 minus lambda and 2 minus lambda. They will also be computed with the 0. 3 minus lambda equals to 0 and 2 minus lambda equals to 0. So what will be the final values of lambda? We will solve these 3 equations. Which 3? This one, and this one. So the final values will be, if I write them here, the values of lambda will be 4 minus lambda is equals to 0. It means the lambda value of lambda 1 will be 4. Then 3 minus lambda is equals to 0. It will be lambda is equals to 3. And 2 minus lambda is equals to 0. It will be lambda is equals to 2. So these are the eigenvalues of the given matrix. So these are the eigenvalues. So this is how you can find the eigenvalues of a 3 into 3 matrix, and this is the easiest way that I have told you how you can find it. So I'll also put the link down that how you can find the 3 into 3 matrix in as quickly as I can tell you, is in just few minutes. And that's all from today's lecture. We will see in the next lecture how you can find the eigenvectors of 3 into 3 matrix. Thank you.